Hi there, my name is Dimitris Charalambidis, and in this video we'll discuss the main concept behind the equation of a tangent at a graph of a function f at a certain point. So once again, our topic in this video will be equation of tangent at the graph of f, graph of a function f at a point. Let's try to visualize this first. Let this be a set of axes. Here we have the x-axis and the y-axis and a random graph of a function. This could be graph of f. At a random point, let's make it here with coordinates x0 and f of x0, I can always draw at any point, so here as well, I can draw a tangent line, which is a line that touches exactly at that point the graph. So this is the tangent line. Tangent at x0. I want you to remember two things regarding this. Two things and the whole idea. First of all, the whole idea is what we just mentioned. We have a graph that at one of a function f, and at any point of that graph, at any point, I can draw a tangent line. This would be a line. So it will have an equation and it will also have a slope. And these are the two things, the two key characteristics that I want you to keep in mind. First of all, the slope of tangent at x0 is equal to f derivative of x0. And this gives us a first interpretation, a first geometrical interpretation of what the derivative means. The derivative of a function f at x0 is nothing more or nothing less than just the slope of the tangent line at that point. Let's visualize this to understand it even better. Again, this could be x and the y-axis. This could be a graph of f. And let me use now different colors for different points. Assuming that this is x1, I can draw tangent at x1, but then its slope would be the value of the derivative at the f derivative of x1. Let me use a different color for a different point. Let us assume that this is x2. The derivative of f, the equation, the tangent would be this. This is the tangent at x2, and the slope of this tangent would be equal to f derivative of x2. Finally, a third point, let us assume that here we have x3. The tangent is this blue one, that's the tangent at x3, and this tangent will have a slope of f equal to f derivative of x3. So again, the geometrical interpretation of f derivative x0 is the slope of the tangent at x0. What do we mean by slope? It's a measurement that shows the line's direction. If a line is increasing, it is expected to have a positive slope. If the line is decreasing, it is expected to have a negative slope, respectively. If the line is parallel to the x-axis, it is expected to have a slope equal to 0. And if the line is perpendicular to the x-axis, it is expected to have a slope that it is undefined. But in any case, any line, so therefore any tangent, will have a slope. So we will be able to find or not, in case it's undefined, the f derivative at that point. The second thing I want you to keep in mind is that the equation of tangent at graph of f at x0 will be given by this form: y minus f of x0 equals f prime of x0 times x minus x0. In this form, x and y, we don't interfere with them. We will just let them be. After all, the equation of a line is a relation between x and y, so we need them to be there. x0 will be given. We need to calculate f of x0, which means go to the given function of f and substitute x0 instead of x. And we also have the f derivative of x0, which means two things. First, find f derivative of x by applying the differentiation rules we already know, and then substitute x0 in it. In one of my next videos, we will work together an example on how exactly to find the equation of a tangent given the formula of the function and the point x0. For now, I simply want from you to remember these two things and the main concept. Once again, at any point of the graph, you can draw a tangent, and the slope of that tangent will be the value of the derivative at that x value. So the slope of the tangent at x0 will be the f derivative of x0, and the equation of that tangent will be of that form: y minus f of x0 equals f prime x0 times x minus x0. That would be all for now. In case any of you has any question, you are more than welcome to leave your comments below the video. As always, thank you for your time.